Welcome to Spring LIB.
Okay, so we got a truck loaded with watermelons. The watermelons fly off the truck. One watermelon has an initial speed of 10 meters per second in the horizontal direction. The bank is shaped like a parabola. And it has the equation y equals, or y squared equals 16x. Y squared equals 16x. It's not really a parabola, but oh well, I think I'm going to go with it. Where does the watermelon hit? Okay, so x is going to equal v initial t. That's it. Y is going to equal a cross section of the bank. It's vertex. I don't know how high the truck is, unfortunately. And I can't get the height of the hood of the truck. So y is going to equal the height, where h is the hood height. It's probably shown in the drawing, but I can't get to the drawing. So y equals h. There's no initial velocity in the y direction, minus 1/2 g t squared. Okay, now y squared equals 16x. So h minus 1/2 g t squared equals 16 times whatever x is. X is going to be v initial t. Okay, so h squared minus 1/2 g h t squared, but there's two of them. 1/2 g h t squared, but there's two of them, so I'll erase that. Plus 1/4 g squared t to the 4th power equals 16 vi t. But the question is, what are the x and y coordinates? Well, if I could solve for t, I could get the x and y coordinates, or, yeah, that would be the easiest thing. So, this is kind of a difficult equation, though, especially since I don't know h. Here's what I would do. I would write this as 1/4 g squared t to the 4th power minus ght to the 2nd power minus 16 vit plus h squared equals 0. Then I would graph it. Let's say that h equals 2 meters. I don't know what it is. And 2 would be too high for the hood of a truck. So I think actually I'm going to guess that it's 1.5. So I'm just guessing, but you may have to do this yourself because I don't know what the height is. So I'm going to put in 1.5 and I'm going to graph it and look for the x-intercept, which would be technically the t-intercept. So y equals 1/4 g squared t to the 4th power. I'm going to put in h equals 1.5. What else do we know here? V equals 10. Okay. So 1/4 g squared t to the 4th power minus gh t squared. And unfortunately, you can't see my calculator. Minus 16 v t plus h squared. Okay, now, again, I'm looking for the x-intercept. The x-intercept is at 1.9. Actually, it's at 2.00 seconds, which is pretty interesting. At 2 seconds. Although, wait a minute, am I going too far here? Because I also have h at 0.014 seconds. That's going to make more sense. That's the first y-intercept. Okay, if that is the t, 0.014 seconds, then x equals v initial t, (0.14) meters, and y equals h minus 1/2 gt squared. So that would be 1.5 meters. So let's just make sure that that works in this equation. So 16 times x just a minute. 16 times x is 2.25. And then on the other side, y squared is also 2.25. All right, so that makes sense. And of course, if that's not the correct h, then I can just put in a different h. Let's say that h was 1 meter. That's going to give me a time of 0.0625. Or if h is 2 meters, then that would give me a time of 0.0249. And then if the time is 0.0249, that would change it to, so I'm saying if h was 2, then that would change it to 0.25. Y is 2.0. So that's another solution, but the problem is that I don't know what h is. So it's probably either this or this. All right, thank you for watching.